Okay, these are new properties. So a rhombus, it's kind of like a square because all the four sides are the same, but it's tilted a little bit to where the angles are not right angles. It kind of looks like a diamond, typically. And then a rectangle, you guys know what a rectangle is? It's a square, but it's like elongated. So not all four sides are the same, but it still has the right angles. Yeah, all right, let's go to page 3. We're just doing one page notes today, so that's nice. We're going to start with rhombus properties right here. So the thing with all of these is it has all the properties we learned about the other day for a parallelogram. So, when it gives you half of a diagonal, you know that the other half is also congruent. Was that listed on our sheet? No, it wasn't listed because it was listed under like the parallelograms. So like the diagonals bisect each other. That is something that's important. And then for a rhombus, angle AED. So like this angle right here is the first one that it's asking for. Okay, well, we know that the diagonals are perpendicular. So under here I'm going to write diagonals are, and then we put a perpendicular symbol because AED is going to be 90. And how do we know that? Because for a rhombus, the diagonals are perpendicular. That's one of those properties. And then ADE. So this angle right here, ADE. Make sure you can identify what the angles are because that's half the battle here. So we have 90, we have 67, and then we have this angle over here, but notice inside it forms this right triangle, right? So this right triangle is formed, and then we can solve for this one. So we've got 90 plus 67, and we want to subtract that from 180 because whatever is left over is this angle. So 23 is going to be ADE. And that's how you solve for that. If it helps, you could do 180 minus 90 plus 67. You can write that out to kind of figure out where that came from when you're looking back. All right, BAE. So this angle right here. Okay, well, we have this property that will help us over here. You don't have to turn back to it, but the diagonals bisect a pair of opposite angles. We talked about how parallelograms do not do this, but a rhombus does. It cuts the opposite angles in half. What does that look like? Well, that means that if this is 67, this must also be 67. So same idea over here. Like if this is 23, that's also got to be 23 because the angles are bisected. So diagonals bisect opposite angles. That's like the property of where that came from, and that's how we know that BAE is 67. All right, and then AE, well, this side is 5, and then this side is also 5, because the diagonals bisect each other. And like, you guys, it might seem redundant to like write these down, where these came from, but I promise it's going to help. If the more practice you get of knowing what properties go with what shape, the easier this is going to be, because it's a lot of information to take in. Okay, and then the last one is BE. Oh, well, we already did it. BE is 12. Oh, it's not the last one. Okay, never mind. BE is 12 because the diagonals bisect each other. So for here, that goes for 4 and 5. We don't need to rewrite it. And then the last one is AB, and then I obviously can't see. I keep saying the last one. Then we got to do the perimeter. Okay, how does this look? Well, we've got to find this side. Notice what we got going on here. We've got a right triangle where one's 12, one's 5, and the other side is the hypotenuse. Pythagorean theorem. Is that familiar to any of you? Well, that's what we're going to do. It's like a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. How did I know to put 5 and 12 there? Well, c is going to be the hypotenuse. How do we know this is a right angle? The only reason you know it's a right angle is because the diagonals bisect each other. Or not the diagonals, the diagonals are perpendicular. So you have to know all of that in advance to be able to solve this. Let me make this a little bigger. All right, and we add those together. 5 squared plus 12 squared is 169. You can't see that, but it is. And then your last step for Pythagorean theorem is to always get rid of this squared symbol. And in order to do that, you have to take the square root. So square root of, So it's like second x squared will get you that square root symbol. And it's the opposite of squaring something, so it will take away that squared symbol. Square root of 169 is 13, and this just happens to come out to this nice, pretty whole number. So AB is going to be 13. All right, we know that this is a rhombus. Therefore, all of the sides are the same length. So if they're all 13, because if one side's 13, they're all 13. In order to find the perimeter, you can do 13 times 4, and you get 52. The perimeter is 13 times 4, which equals 52, because all sides are congruent. Okay. I mean, there's really just two main properties with rectangles. One is that they have 4 right angles, so, you know, it's possible that some might ask you, like, it'll give you an angle of a rectangle, and it'll say, this angle is 4x minus 2, and you'd have to, like, set that equal to 90. There's not an example like this in the notes, but just know they have right angles if that pops up for a square or a rectangle. That's how you solve that. But, like, in this case, the lengths of the diagonals are given, and we know that diagonals are congruent on a rectangle. Is that the case on a rhombus? No. Is that the case on a square? Yes. All right. Diagonals are congruent for a rectangle and for a square, but not for a rhombus, not for a parallelogram. All right. Okay. So we're going to write that. Diagonals. Oh, there we go. Yeah, that's how you spell it. Are congruent. Diagonals are congruent. So that's pretty easy. We can just set them equal. If two things are the same and you want to solve for x, you need to set them equal. 4x minus 1. We're going to subtract 3x on both sides. 4 equals, that just becomes x, because 4 minus 3 is 1. Then we're going to add 1. 5 equals x. It says find the lengths of the diagonals. So 5 equals x, but we need to plug that back in. They should be the same. So this is a good way to check yourself. 4 times 5 minus 1 is 19. So one of them's 19. The other one should also be 19. 3 times 5 plus 4. Oh my goodness, they're both 19. Then we did it right. Okay, I'm going to pause real quick and give you guys a chance to solve number 9. Okay, so I ended up getting 22 for the answer. I'll kind of walk you through this. I started by subtracting 6 on both sides, and then I got that. And then a lot of times people get stuck here because they want to, like, go ahead and multiply and get rid of this, but you got this 7 over here, and you can't do that. So you have to subtract. I mean, there are other ways to do it, but I subtracted 3 halves, so 2 minus, it's essentially 1.5 is what it is. And you get 1/2 x when you do that, and then if you multiply by 2 on both sides, you get 14. Alright, this was pretty easy. It's squares, so it's all the properties of literally everything we've been learning the past couple days. So AEB, well, the diagonals are perpendicular, so that is important for this one. So that would mean AEB is 90. I mean, here's the thing with these properties, though. You're going to have, like, pictures like this, and you're going to know, like, typically you'll know what the shape is, but it has to come from your brain, like, are these perpendicular or not? So like a parallelogram, they're not perpendicular. A rectangle, they're not perpendicular. So you can't just like say, oh, all the things with four sides, their diagonals perpendicular. That's not the case. You have to be able to like decipher the difference and know which property goes to which one. So I'm not trying to scare you, but you just make sure you know that. And the pictures don't always look exactly perpendicular. I don't know. In my brain, this doesn't look perpendicular. I mean, it is, but I don't know. And then EAD. So this angle right here, EAD, we know that one of the properties for a rhombus, which also works for a square, is that the diagonals bisect opposite angles. So diagonals bisect opposite angles. So, oh, I don't know why I said 90. This whole angle is 90. You cut it in half, you get 45. And voila, you have this angle. Beautiful. 45. That, I didn't mean to put that. Let's erase that. And then the last one. And this one actually is the last one. Find AD. Ah, yes, more Pythagorean theorem. So we know that this is 10. We know that the diagonals bisect each other. So this would have to be 10. This is 10. This is 10. Because, so the diagonals bisect each other, but they are also congruent. So the whole thing for both of them has to be 20. That's why with just 1/2 of one diagonal, we can figure out everything. And then Pythagorean theorem again. This one does not come out to a pretty number. It ends up being a decimal, but that's okay. So we've got 10, and we're looking for AD, so that's our question mark. 100 plus 100 is 200. And then you take the square root of both sides. Later on this year, you will learn how to simplify radicals. Some of you probably already know how, but we'll do that later. But for right now, it's going to be a decimal. And square root of 200 is 14.1. And that's approximately the length. And then all four sides are 14.1 units long.